A 270 meters long train running at a speed of 120 kilometers per hour crosses another train running in opposite direction at the speed of 80 kilometers per hour in 9 seconds. What is the length of the other train? Well, let us consider that the length of this other train be x meters. Now let us calculate the relative speed. Well, these trains are traveling in opposite directions, which means that the relative speed will be the addition of the respective speeds of these trains. So we have relative speed as equal to the speed of the first train is 120 kilometers per hour plus the speed of the second train is 80 kilometers per hour, and that's 200 kilometers per hour. Let's convert this into meters per second. That's 200 times 5 by 18 meters per second. So we have the speed. Now the relative distance will be the addition of the lengths of the trains. So the distance is equals to the length of the first train is 270 meters plus the length of the other train is what we have to find, and we have assumed it as x meters, so plus x, and the time is given to you as 9 seconds. Speed is equals to distance upon time. So we have speed as 200 times 5 by 18 is equals to distance is 270 plus x upon time is 9. Now 9 times 2 is 18. 2 times 100 is 200. So we have 100 times 5, which is 500, is equals to 270 plus x. So x is equals to 500 minus 270, and that is equal to 230 meters. So option A is the correct answer, which is the length of the other train. Two trains, each 100 meters long, moving in opposite directions, cross each other in 8 seconds. If one is moving twice as fast as the other, then the speed of the faster train is. Well, let us consider that the other train's speed be x kilometers per hour. So it is given that the faster train is twice as fast as the other train. So the speed of the faster train will be twice x kilometers per hour, right? Now these trains are moving in opposite directions, so the relative speed will be equals to the addition of their speeds. So x plus 2x, that's 3x kilometers per hour. Now convert this into meters per second, and to do that we'll have to multiply it by 5 by 18 meters per second. So you have the speed. Now what is the distance? Distance is the addition of the lengths of each train, which is 100 meters plus 100 meters, that's 200 meters. So that's the distance, and we have been given the time, which is 8. So speed is distance upon time, so we have 3x times 5 by 18 is equals to the distance is 200 upon time is 8, that is 50 by 2. 4 times 50 is 200, 4 times 2 is 8. So you have x is equals to, we can cancel this out, 3 times 6 is 18. So we have x is equals to 50 by 2 times 6 by 5. 2 times 3 is 6, 5 times 10 is 50, and that is 30. So x is 30 kilometers per hour. Why kilometers per hour? Because we assumed x unit as kilometers per hour. So the speed of the faster train is 2x. So we have 2 times 30, and that's 60 kilometers per hour as the speed of the faster train. So option C is the correct answer. Two trains are running at 40 kilometers per hour and 20 kilometers per hour respectively in the same direction. The faster train completely passes a man sitting in the slower train in 5 seconds. What is the length of the fast train? Well, these trains are running in the same direction, which means that the relative speed will be the difference of their speed. So speed will be equals to 40 minus 20, and that is 20 kilometers per hour. Now let's convert this into meters per second. So it is equals to 20 times 5 by 18 meters per second. Now you have been given the time this train requires to completely pass this man sitting in the slower train, and that is 5 seconds. So time is 5 seconds. Now in order to completely pass this man sitting in the slower train, the train will have to travel its own length, but at a relative speed. So we have the formula for distance. Distance is equals to speed into time, and that is equals to, the speed is 20 times 5 by 18 times the time is 5. So 2 times 10 is 20, 2 times 9 is 18. So you have 5 times 5 is 25 times 10 is 250 by 9. Let us divide 250 by 9 now. So you have the answer as 27.7 by 9 meters. That is the length of the fast train. So option D is the correct answer. Two trains running in opposite directions cross a man standing on the platform in 27 seconds and 17 seconds respectively, and they cross each other in 23 seconds. The ratio of their speeds is. Let us consider the speeds of these trains as x meters per second and y meters per second respectively. Now let us find the length of these trains. Now it is given that these trains cross a man standing on the platform in 27 seconds and 17 seconds respectively. So to cross a man, the trains will have to travel their own length. So we can now calculate the length of the trains. So the length of the first train is equals to the speed into time. The speed is x meters per second into time is 27. So 27x. And the length of the second train is y, that is its speed, times its time, which is 17. So 17y is the length. Now we have also been given that these trains cross each other in 23 seconds while traveling in opposite directions. Now as these trains are traveling in opposite directions, we can calculate the relative speed. So the relative speed is equal to the addition of the speeds, which is x plus y, and the relative distance is actually the addition of the lengths of the trains, which is 27x plus 17y. And we have been given the time, and the time to cross each other is 23 seconds. So we have the formula speed is equals to distance upon time. So x plus y is equals to, the distance is 27x plus 17y upon time is 23. So 23x plus 23y is equals to 27x plus 17y. So 23y minus 17y is equal to 6y, which is equal to 27x minus 23x is equal to 4x. So what we want is the ratio of the speeds of these trains. So what we want is x by y, and that is equals to 6 by 4, and that's 3 by 2. So 3:2 is the ratio of the speeds of these trains.